Let's begin with this problem right here. We want to solve this system of equations. So, how can we go about this? Well, what I'm going to do is I'm going to label these equations 1 and 2. Right? And here's how we're going to solve this. Right? We can just add these two together. So 1 plus 2. Maybe we should call this problem 1, P1. Right? If we add 1 and 2 together, we get that 3x equals 6, and so x equals 2. Okay? We plug that into equation 2, and this says that 2 minus y equals 2, which will tell us that y is 4. Okay? So we get that the solution to this is x comma y equals 2 comma 4. Right? Let's look at another problem that's pretty similar to this. Call this one P2. Okay, this time we're going to have the system negative x plus y equals 1 and 3x minus 3y equals 4. So again, I'm going to call these equations 1 and 2, and we want to try and figure out, well, how can we solve this? Well, we can, try and combine the rows. We can also multiply an equation by a number and then add them together. For example, here I might want to do 3 times equation 1 and then add it to equation 2. So I'm going to make this look kind of like arithmetic here. So 3 times equation 1, so that's negative 3x plus 3y equals 3, plus equation 2, that's 3x minus 3y equals 4. Okay, add these together and we get 0 equals 7, right? Because these two will cancel and these will cancel. Well, this is just false, right? This isn't true. So what does that mean about this system of equations here? Well, this means that there's no solution to this, right? If you get a false equation like this, there's no way to answer this problem. So there's one more thing that can happen, right? So before we solve another example, I want you to think graphically about how these solutions happen. All right? I want you to think about, here we have a solution that's just one point. All right? These equations here we're graphing in R2 in the xy plane. The graphs of these two things are both lines. And here we get one point as a solution. Okay? Think about what that means. Here, again, these are two different lines. And here we have no solution. So think about the graphs of these lines and what they would look like in the case of no solution. Right? Now, think about it. There's a third option here. What does that third option look like? What does it do? Well, let's do an example and see, at least algebraically, what's going to happen. So P3. Let's see here. We got 3x plus 2y equals 2, and 6x plus 4y equals 4. All right? So again, equation 1 and equation 2. Right? I like doing this. It'll be a nice bookkeeping method. All right? So let's do our arithmetic again. If we look at this, if we do 2 times equation 1, and then this time, if I multiply this by 2, these are both going to be 6x. So let me subtract equation 2. Okay, so 2 times equation 1 is 6x plus 4y equals 4. And then we're going to subtract 2 times this. So this is 6x plus 4y equals 4. Now keep in mind we're subtracting here. Well, everything cancels. And this is true. Right? This one is true. Right? The last one was false, but this one's true. What does that mean? Well, what it means, if you look at these lines, right? The first or the second one is just 2 times the first one. So they're really just the same equation. So there's really only one line here. So what that means is the graphs of these two lie right on top of each other, which technically means there's infinitely many solutions. How do we write that? Well, so first off, let me say that there's infinitely many solutions. Right? How do we write this out? Well, what the first thing we're going to do is we have to pick x or y and say that that's going to be our parameter. So we're going to choose x equals t. This here, this t, is called our parameter. Right? That should remind you of writing down the parametric equations of a line, or the vector equation for a line. Right? We had that parameter t every time. So anyway, so we choose x equals t, and then what does y have to be? Well, we get 3t plus 2y equals 2, and so y has got to be 1 minus 3/2 t. Right? We just solve for y here. So what's the solution here? Right? The solution is xy equals t comma 1 minus 3/2 t. So that's our solution. Now, I really want to emphasize the connection here with equations of a line, with the parametric and vector equations of a line. Right? So we're going to rewrite the solution to this. Right? So we have this here. Let me move this down here. Right? And what we're going to do to this is we want to split this into 2 pieces. A part with only constants and a part with only t's. So the first component has no constant, so it gets a 0. The second component has a 1, so the constant part is 0, 1. And then it's plus t comma minus 3/2 t. Now, an even better way to write this is 0, 1 plus t times 1 minus 3/2. And hopefully this reminds you of the p plus tv stuff. Right? Because the solution to this really is a line. We have a point on the line and a direction for the line. Right? So I really want to emphasize the connection here. Right? So let's look at this graphically. Let me pop this up. So the first system of equations we had, the graph is right here. Right, so the blue one's the first one, the orange one is the second one. And we see that it's crossing. Let's see. Did I miscalculate something? I sure did. So hopefully some of you guys caught this. I completely solved this. This should be a 0 here. So this should also be a 0. 2 minus y equals 2. Y should probably be 0. Alright, sorry about that. So let's pull this back up. So here's our solution, 2, 0. So it's where these two lines cross. Well, did you figure out what was going on in the second problem? Well, when we graph the solution of that, we get parallel lines. Right? And if we look at these, there's no places where they cross, so there's no solution to the system of equations. Right? And then finally, oops. Here, again, there's a blue line, which is the first equation, and an orange line, which is the second one. But notice the orange one's just right on top of the blue one here, meaning that they have the same solution. All right? And here, let's see, we decided that 0, 1 was a solution. Well, here's 0, 1 right here. And then the direction is 1, negative 3 halves, which means it points to the right and down. Well, starting from here, if we go to the right and down, we get some line, and then the negative of that puts us this way. So this is that line that we found the equation for. Right? So hopefully this gives you kind of an idea of the direction we're going here and how it relates to what we were just talking about. So in the next video, we'll talk about this, but with 3 variables and what can happen.